Welcome, welcome to Presto, you got it, where we use insightful comments and analysis to make your learning easy, interesting, and fun. In addition, on academyforadvancedstudy.com, at a very affordable price, we offer many tutoring programs to help you. We cover SAT, ACT, AP, all the college prep materials. We also cover K-12 subjects. We even cover college level materials. Again, at a very affordable price, we offer tutoring program for advanced topics in statistics, computer science, and data science. We also cover programming and engineering, Python, Java, JavaScript, HTML, CSS, everything you need in the age of AI. If you want to go to medical school, we can help you too. Again, at a very affordable price. We offer tutoring program for MCAT. Now, let's go back to our talk today. What we're going to talk today is line KWS property in Seaborn. That's Python's statistical data visualization library. Let's take a look at what we can do here with line KWS. So this notebook, we demonstrate how to use the line KWS parameter in Seaborn to customize regression line. Actually, it's not just a linear regression line. We can also customize logistic and even polynomial regression. We will use a fictitious data set about study hours and the exam score. So what we have here is to first, in the first code cell, we are going to import all the library we need. Let's run the code. What this does is that we first import Seaborn library as SNS, that's Python's statistical data visualization library. Next, we import matplotlib, specifically pyplot module, to manage our plots and figures. This is Python's data visualization library as well, but they function differently from Seaborn. They offer different features and properties. Next, we import pandas. Pandas is data manipulation library in Python. We need that to build our data frame. We next import NumPy, that's Python's numerical computation library. We need that to generate random data points for a fictitious data set. Now we are ready to produce our fictitious data set. The data set is about two variables. The first one is hour studied. The second one is exam score, meaning how many hours a student studied and what's that student receive on the exam, the score. Let's run the code here. As you can see here, we have several rows of fictitious data set displayed after we generate the data set. We first set the seed. This is important to ensure every time we run the code, we receive the same data set. This is to ensure the reproducibility of our program. Next, we generate random data points for hours. So that's hours between 1 and 10 hours. We generate 30 such data points. Next, we generate scores. The way for us to do that is we did this in 3 parts. The first part, we have a base score of 45, meaning even a student study 0 hours. he still received 45 points. But of course, it's not enough. For the second part is the number of hours multiplied by 5. What this means is that for every hour studied, the student receives 5 more points. Next, we need to add some random noise. Nothing is perfect in real life, so sometimes you don't get what you think you should get. So we introduce random noise here. The way for us to do that is to use normal distribution with mean of 0 and standard deviation 5. Again, we produce 30 such data points. Next, we use, so notes here, the first 3 lines, we all use NumPy, so you know now that NumPy is used to produce random data points. Next, we use pandas to construct data frames. So note here we use PD, that's a panda library we imported earlier. What we are doing here is to construct 2 data columns. The first one is hours studied. The second one is exam score. The hours studied column, the data come from hours variable we constructed earlier. The exam score column, the data come from the scores variable we constructed earlier. Next, we use head to print out first 5 rows of data set. So what we see here is the first student studied 1 hour and received 52 points. The fifth student studied 2 hours and received 55. Right. So let's continue our conversation, and that's next step. We are going to produce a default regression plot. What we want to show here is that if you do not give any specific instruction and just use the default, what Seaborn will do for you. So let's run the code. So we have regression line together with all the data points in a scatter plot. So when we run this code, we only give the minimum instruction Seaborn needs to know to build this regression line and the data points. So we first supply the DF, that's the data frame we constructed earlier with hours studied and the exam score columns. Next, we specify which column should be the x-axis and which column should be the y-axis. Next, we give the title of this plot. So that's our default regression line. And then we say, okay, grid. We do want the grid line. It's quite convenient for us to have a grid because it makes it easier for us to identify the data value for each data points. Next, we use show to display the figure. Note here that the first line we use Seaborn, that's SNS regplot. The next 3 lines we use matplotlib. Now you know what difference these 2 libraries are, and how we can combine them and use them together to produce what we need to produce. So this is a default when you do not specify anything special. Next, we're going to customize a little bit. The first one we have is to introduce a few parameters. Let's run the code first. Oops. Okay, now what we have, we use color, line width, line style. So the way for us to introduce this is through the line KWS. KWS stands for keyword arguments. That's what the Seaborn will take, and it's actually a dictionary. And the Seaborn will use this to guide how the regression plot will be produced. Here we say for the line, okay, we want to color red. That's what the line here means. It's just to specify the regression line. Note here the data points are still in color blue. Only the line has color red, which is what we instruct the Seaborn to do. And the line width is 2, so this makes the line a little bit thicker. And the line style, we want to dash the line, so note here, it's a line style, not lifestyle. So that gives us a different regression plot. Sometimes you want to customize for your presentation, so make sure you got your audience attention. Next, we do the same thing, and we say, okay, we want grid true, and we show the plot. Again, the first line is comes from Seaborn SNS. The next 3 lines we use matplotlib. So that's our first customization. Next, let's run the code here first. Oops. See here we have 2 figures, 2 plots, and they behave differently based on our instruction. So here we have first customization we have here is to say color green. So we want the line, and note here it's a line KWS. We have a different parameter, that's a scatter KWS. So line color needs to be green, and line width is 4, so it's much thicker. 4. So what we have here is a thick green line. Next, we show a different plot, and that's this one here. Now let's go back to the code. So with the second plot here, we say line color needs to be blue, and the line style we want a dotted line. We use colon to specify that. And we also say, okay, we want some transparency here for our line. Sometimes you want that. A lot of times we want transparency specification for our data points. But sometimes you do want to change the transparency level of your line. So we have 0.6, which means the line is 60% visible, 40% transparent. So let's take a closer look of these 2 plots. The first one, we have a thick green line. Note here what we specify is only for the line, not the data points. And the second one, we have different color for the line, and we also have transparency. What we can do is that we can actually, you note here the line, the strength here. Well, not exactly the strength in the statistical sense, but the transparency, the opacity is different from the previous plots. So we can actually change 0.6 to something even more significant. So let's see, we change this to 2. Let's run the code again. Before we run the code, let's take a closer look what we have with 0.6 transparency alpha. And now let's go back. So let's actually give you a few moments to internalize what it looks like with 0.6 alpha value. Now let's go back and run the code here. Now you can see the effect of transparency much easier now. This is 0.2 value for alpha or transparency for the line. Note here we're not changing anything about the behavior data points. Next, we're going to show how line KWS parameter work with LM plot. In the first few examples, what we show is the reg plot, that's a regression line plot. Here we show how it works with LM plot. So let's run the code. So it's almost the same thing we can do with reg plot. So we see line KWS, color is purple, and line width is 3, so a seeker. And so very similar to what we can do with reg plot. In summary, we see line KWS customize regression line properties in Seaborn plots. Note here, it's not just a line. For example, with LM plot, we can produce logistics regression and also polynomial regression. And we have quite a few useful options: color, line width, line style, and alpha transparency. It works with both reg plot and LM plot. This allows for better visual styling in your regression plots. Alright, that's all we have today. Remember, on academyforadvancedstudy.com and academyforadvancedstudy@gmail.com, we offer at very affordable price many tutoring programs to help you. That's all we have today. Thank you and have a great day.